So, welcome everyone. We are ready to begin Pushpi and Isabela's talk. They're at professor and student at St. Mary's College in Indiana, and they're going to share with us about enhancing differential equations instruction through modeling, visuals, and projects. Take it away.
Sorry. Hello. Thank you for the very nice introduction and thank you for having us here. So, I'm Pushpi and Isa will be talking after me. So we will be talking about how we change how I change differential equations instructions through modeling activities, visual aids, and final projects. And we will talk about my reflections and student reflections and her experience. Just to give a little bit background, we have two differential equations classes. Like the first one is more linear algebra, and then we have it's like introduction to differential equations, first order, second order, a little bit of differential equations. The class I'm teaching is more higher order differential equations, and then linear systems, linear and nonlinear systems, phase planes, so cool stuff, and then Laplace transform. Fourier series, and I do a little bit introduction to heat equation, and then that's about it. That's the end of the semester. So I wish we had more time to do PDs, but we don't. The class is mostly math majors, and there are a lot of engineering students. We have a dual degree program with Notre. So we have a lot of engineering students and some chemistry and physics students. So I want to talk about why I did this whole thing. So I taught like 4 times, I think, already. The first time I was teaching this class, I did it in a very traditional way. I taught the technique. I did one example. They do one example, and it's so boring. I mean, the students learned well. They mastered the techniques. They did the homework. Final exams were great. They came to office hours, but for me, I really wanted to I mean, they saw my enthusiasm, but I wanted to show the beauty and the potential the differential equations have. Teaching bunch of techniques won't just do it. So I was like, what should I do? And then I was searching online, and then I came across some similar resources. And eventually I went to a session at JMM, and then I really learned about these different modeling techniques that you could use to motivate students, and then give exposure to, real world applications of differential equations. So I was like, I'm going to do some of these things. So today I'm going to talk about 3 things that I developed and implemented in some of my classes. One is first day modeling activities, and then I will talk a little bit about some visual aids that I used throughout the semester. Finally, how I used final projects instead of writing exams. So first of all, it's the very first day. I was not going to teach anything about differential equations. I just went to the class, and then I gave them the worksheets and M&Ms. They were like, what's going to happen? One of them was like, okay, this is not like a math class. This is like a physics lab, but I think in a good way. So I was excited. Since you are here, I'm assuming everybody knows what M&M activity is. So this is your expo. So we model population change over time using M&Ms. And over time, like in different classes, I used variations where some groups used M&Ms, some groups used this. This is a type of seeds, and the other one is a seashell. So this allowed me to talk about what different assumptions we make, what the parameters represent, what if we have different conditions, how could you model these things? So using these different things, I could talk about these assumptions or what the limitations of the models are and how you could improve these things. So without teaching any differential equations, I started the discussion about these modeling activities. And then they actually saw, okay, this is the differential equations, and we actually modeled the differential equations, and I didn't ask them to solve anything. And also the class was about higher order differential equations. This is a very basic differential equation. That was fine. I just wanted to set the tone for the class where they see the ideas and real world applications of differential equations, basically. And also I did a potato cooling activity where we used the Newton's cooling law to model the temperature of a potato. So not only just the first day, and then during the semester, I kind of tied the discussions into this modeling activities. So usually if I teach one day and the next day, if I go to class and ask what we did last time, they will be like, they don't remember. But if you ask something about this activity, they would remember and they will answer answer for the questions in terms of these things. And I think it kind of improves their critical skill, thinking skills as well. So it was a fun activity, and also it set the tone for the class. Gave an insight to differential equations and also exposure for modeling. Some students were really inspired about these real world scenarios, and Isa was one of them. She wanted to do research and read more papers with me in differential equations. So I felt happy. Like I felt like I was successful in showing the beauty of the subject. So students were excited, and also they were connected. From the start, from the first day onwards, they got connected with each other. So it was a fun semester. All right, so the next one is I used different visual aids, videos, simulations. I used Desmos, plots and things like that to show the pictures and things like that to show what we were talking about. But these three videos, I showed them to actually, I don't know if I can, I think I have to share again probably. Do you see my videos? Probably not. Yeah.
I still see your slides.
Yeah. Slides, yeah.
Mm-hmm.
So I think I have to do it again. Okay. So this one, you might have seen these things. So the first one is when a physics teacher knows his stuff. So we talk a lot about pendulum. So I showed this to show what a dynamical system or a differential equation actually tells you. It's the motion of the pendulum over time, and it's a deterministic model. What the assumptions are, this teacher releases the pendulum, and okay,
I don't want to see this. So please be very quiet.
you probably can't hear. I'm so sorry. I don't know.
I almost didn't sleep.
So
We can hear it. It's good.
Yeah, okay. It's so this was exciting for the student to see, like, okay, it's we have these equations for the pendulums, but we can trust these equations basically under some assumptions, though. So the other one was we talk about pendulums, damped pendulums, undamped pendulums. These were, I think the students really liked these ones when we were talking about stability of stability analysis, phase planes and things like that. Can you see the video? hoping, yeah. So they can actually see the phase plane and also how it corresponds to this actual pendulum. So I found these two other videos for damped pendulum and undamped case. So these were very helpful for the students to see. I'm not going to play the other one. I'm going to move on. So these were some things I showed in class to motivate and keep the students engaged. P-plane, I think everybody knows. So to show the phase planes, I used P-planes or sometimes decimals as well. So finally, projects. This is the most interesting part for me because the first time I taught, as I mentioned before, I just gave final exams like everybody does, 3 mid exams and final exams. And then I was like, no, there has to be another way. So projects are cool as in they see real problems, real applications, at least like simple models of real problems, and that gives them some exposure to research world if they are interested in that. And so I'll explain a little bit about how I did these things. So I gave projects, final projects instead of final exams, and groups of 3 to 4 sometimes. Assessment type is I asked them to do a group presentation. Everybody has to present. And they have to write a 3 to 5 page report. So here I think you kind of have to limit the number of pages, otherwise they're going to write like 20 pages. And initially, when you say 3 to 5 pages, the students are going to question that, how are you going to write all these calculations? So then what I do is I talk about the 3-minute thesis competition, and then I tell them, like, you have to talk about your PhD thesis in 3 minutes. Then they just rub their head around, okay, you can do this. The idea is you have to really pick up the most important parts you want to present, you don't have to say everything. So that's also a skill that you have to develop. So I guess eventually they buy in. So that's the assessment. And also I make sure everybody's accountable. This is really important because in group projects, sometimes there are really good students, they would just do it. And that's not what we want. Everybody has to participate. And there could be a student who wouldn't do anything and just lead on other people. So what I did was I asked the student to assign leaders for different sections and also submit an individual report of their contribution. And peer evaluation form, this is really interesting. I think it's really valuable. I gave a form to fill out. They have to kind of rate their peers and themselves. So they will rate numerically, and also there are, I can show you if you want to later, like there are specific questions like name one thing that others learned from you, or name one thing that you learned from another person, some specific thing. And also there are questions about their group dynamics. So if there are problems, they would definitely say it because they just send it to me. So you can kind of understand the group dynamics on that and then decide if you have to intervene or something. So I didn't really have problems that much. So that's a really good way to make the people accountable. So you can basically assign part of the grade using that individual component if you want to. So I want to talk a little bit about preparation on my part. So when you do this, it's not like writing an exam sometimes. So especially the first time, you have to actually sit down and figure out what projects you want to assign, what's the difficulty level you want to assign. Is it too difficult? Things should not be too challenging and not too easy, and all the groups should have a similar difficulty level. So the first time I will talk a little bit about the projects. the first time I had a really small class, like 10 people. So I went through Simioid resources and found these 3 projects, zombies and algae population and Van der Pol oscillator. They did a really good job. That was the first time. I was so nervous because I didn't know how it would go, but they enjoyed it. The last semester I had a rather larger class, so I had to find more projects because I'm going over time. So I used this textbook. They have projects in the textbook. So I did all these 7 problems. The cannibalism and Van der Pol oscillator are from Simioid resources. All the other problems are from the textbook. I'll quickly talk about how it went. So some success stories, especially last semester, they were super engaged and I saw a lot of aha moments. It was so much fun. They had so much fun. And also some groups did like research on other applications, especially the Van der Pol oscillator group. They did like relations to other applications. What are the connections to other things? And they enjoyed it. The one group who did humans versus zombies, they actually did a brilliant job. They coded a game and considered the St. Mary's as the population and what happens after a zombie apocalypse. So we had really engaging presentations, and then so the point I wanted to make was you have to use the techniques and then you have to explain the class. What's the problem statement? How do you use these differential equations techniques to solve your problem, and what are your conclusions? So we have good communications presentations with good communication skills. Lessons learned. Okay, I'm going to take 2 more minutes. It was a new experience for students. So the first time I did this, the students were really nervous. They were used to doing final exams. They were super like nervous and they didn't know what was going to happen. I realized I should have been more transparent about the experience. So last semester, I actually told them, yes, it's a new, different experience, but there's nothing to be scared about. I had to do some cheerleading. So one of my friends said, maybe add a small section in your syllabus saying what the benefits are of doing these things. That way they can actually read and understand why we are doing what we are doing. So I thought that was a good suggestion. And group dynamics could be challenging sometimes, and finding projects with same difficulty level could be challenging. Enhance student understanding, engagement, critical thinking, all good stuff. They actually saw the bigger picture and less grading, which was good for me. So I will tell you one quick story, actually 2. So a lot of them saw actual applications to their own fields. They were civil engineers. One girl was like, I saw concrete. I was like, okay, I'm going to do this project. And she was super excited about doing the project about the bridges and things like that. The first time, as I told you, the students were really nervous, but that was because they didn't know that they were doing great. And at this end of the semester, they knew that they did great. So after the class, last semester, I met them outside the classroom. All they remembered was about the projects, how they enjoyed the project. So even though they were like nervous, that's what they remembered. And they were happy that they are seeing those things in their engineering classes as well. So I feel like that was the whole point I wanted to make. And I think I was successful. Anyway, next time I will do it, but I'm going to give time to Isa to talk about the next.
Hello, my name is Isa. I'm a senior at St. Mary's, and I took differential equations with Professor Pushpi. So, next slide. So, as Professor Pushpi talked about, there were 3 ways that differential equations were used: the first day, and then the visuals, and the projects, and that's will be the same order I'll go in. So, on the first day of differential equations, I was very nervous. As she explained, we split it up here at St. Mary's, and I hadn't taken the linear algebra and differentials part 1 in 2 years. So it was like coming in, basically starting fresh again, with like knowledge of differential equations. And so at first I was thinking like, what's the whole point of this? You know, when you think in math, like you can do things with calculus, but people are always asking like, oh, I haven't used like the Pythagorean theorem in my everyday life. Like math has no point. But I mean, I love math, so I took the class. And so I really loved, I got the M&M activity. I did not do the potato one, but my group did the M&M activity with immigration, and it really helped me to see like, oh, you can actually use math like to do real life things. It's not just like we're looking at equations on a board and getting to solve them. Like you can actually see this in everyday life. So that's what I did for the first day. And I really liked it. I love the activity. I think it's great. You get to talk to people, and I love talking and getting to know my classmates. So I really liked the first day activity. And it's nice to not just listen to a syllabus on the first day. So the two visuals that I remember, like visibly, like I can still see them in my head, was the heat conduction rod and the pendulum. We talked so much about the pendulum. Obviously, she presented videos and everything with that, and I just remember them like, oh, that actually makes sense. We can see that. And every time I look at a clock, I can see it. But the heat conducting rod, I can see, like I can feel like I could draw the drawing that Pushpi does when we were talking about that one. It's just, it really helps you to see like, I mean, I don't often see heat conducting rods. I'm just a regular math major here at St. Mary's, but it's just like, oh, even when I'm taking the exam, I can be like, okay, I remember doing this because this is what she drew when we did this part. So I really like the visuals and they help a lot. So, but my favorite part is the final projects. I love the final projects. I think that they are so great. I think that they allow for creativity and like your personality to show. Nobody likes taking a final exam at all. I wouldn't say that I even do. And so I really love that you get to present them. I also think it helps when talking about math. One thing that Professor Pushpi really tries to help us with is not going through the equation and being like delta over alpha, and that's the equation. It's being like, well, my project was about cannibalism. So like prey, number of prey over the prey constant. So like talking about it like that. And it's really helpful because if I were to go into onward in life, it's good to talk about them. So I really love the final projects. It also helps to show that like she was talking about the civil engineers were talking about, oh, I like concrete. You don't know how much like you can use math in like non-STEM related jobs. Like the murder mystery project is like criminology, and ours was cannibalism, which is a lot related to like biology. So it's just really cool to see different ways that math can be used, especially differential equations, because it's not one that you ever think about or that people ever talk about. People only talk about like algebra or calculus. So I really liked it. And then I really like watching other people's presentations, because when we go through these presentations, it's not like we just present and then we get to sit down and that's our final. Like we have to like almost like back up, because then Professor Pushpi asks us questions to make sure that we really understand it. So it's not like we're just presenting. It is kind of still like a final. Like you still have to really know what you're talking about and really understand it. So I really like the final project. So my project was about cannibalism, and we used the Lacta Voltura predator-prey model with holding to response. And when I think of a phase plane before, I was like, I understand, I can draw them, I can find them, do all that, but it means like conceptually, like in space, I have no connection to like what this would tell me in the future. And so this project really, really helped me to see that like, oh, from this, I can tell you that if I increase this part, then this happens. And it shows that on the phase plane. We talked a lot about that in our project. That's mostly what our project was about. And so it really helped me like tangibly grasp the concept of a phase plane. So I really like these final projects. They're so much better. And like my group still, like I think that we could still present on it and do it really well. So I think that they're really great. And they help a lot with creativity. I love talking. And one thing we like to do in our presentations is add a funny slide in the beginning. So we added a silly slide in the beginning because it was about cannibalism. It was, what do these three pictures have in common? That is Armie Hammer, That is a tiger salamander and a spider crab, I believe, or crab spider. And those three pictures have in common cannibalism. So I really like them because you get to have your personality involved. You're not just sitting in the room for the 2 hours you're taking your exam, and you get to see the applications of math in real life. So that is what I have to say.
Thank you.
Thank you both.